So this video is going to be a continuation of the mole and mass calculation, specifically the questions relating to the use of mole ratio in a substance. This is only one example of mole ratio. There is another one that we're going to talk about next semester. But in this particular case, you can think of mole ratio as the ratio between the number of atoms of each element in a substance. And it can be determined by looking at the subscripts in the chemical formula for that substance. So for example, if I have H2O, you can see here that in order to make one molecule of water, so one molecule of H2O, one molecule of H2O has two atoms of H and one atom of oxygen. So if you look at the formula for water, you can see how many hydrogen and oxygen atoms are required to make H2O. And from here, I can create a mole ratio between hydrogen, oxygen, and water. So the number of mole, because essentially, if I have 1 mole of H2O, in order to make 1 mole of H2O, I also need 2 mole of hydrogen and 1 mole of oxygen. If you understand what a mole is, then this would not look so counterintuitive, which it normally does for students. Essentially, you can replace the number 1 molecule with 1 mole, because 1 mole is just a lot more molecules than 1 molecule. It's just 602 billion trillion molecules. So if you want to make this many molecules of water, you need to have twice the amount in hydrogen, because 2 hydrogens will come into 1 water. If this translation from molecule to mole is too weird for you, you can replace, like if I have a dozen molecules of H2O, then in order to make a dozen molecules of water, you do need 2 dozen atoms of hydrogen. So it's not that they went somewhere else. Like 2 dozen atoms of hydrogen will go into 1 dozen molecules of water, and you need 1 dozen atom of oxygen. So basically, the mole it's the same. Now from here, I can create mole ratio. So it is a ratio, so I can write the number of mole of water, for example, over the number of mole of hydrogen. So if you want 1 mole of water, you need 2 mole of hydrogen. So that's the subscript. I can also create a ratio between the number of mole of water and the number of mole of oxygen. And in this case, the ratio is 1 to 1. For you need 1 oxygen atom to create for every water molecule. And obviously, you can take the reciprocal of these ratio depending on what is your unknown and what is your given. So we're going to see how the mole ratio can be used in specific examples. So let's start with example 10. So let's start by summarizing the question. How many moles of hydrogen atoms? So the question is asking for the number of mole of hydrogen atoms. So this is my unknown. How many mole of hydrogen atoms are in 6.8 times 10 to the power of, I'm going to change this to 15 so it doesn't look so ridiculous. So 6.8 times 10 to the power of 15 molecules of water. So the information given is the number of molecules of H2O. So this is 6.8 times 10 to the 15. So you have to go from the number of molecules of water to the number of mole of hydrogen. Now, a few other pieces of information that is not explicitly stated in the question, but you should be able to work out yourself, is Avogadro's constant, which is 6.02 times 10 to the 23, and also the ratio between the number of mole of hydrogen and the number of mole of H2O in order to make so this ratio is the same as this ratio. I'm just taking the reciprocal here. So in order to make 1 molecule of water, I need 2 hydrogen atoms. So you're going to have to use all of that information to do this question. this is my starting point, the number of hydrogen molecules. So sorry, the number of water molecules. So I'm going to convert this to the number of mole of H2O. So the first unknown is going to be number of mole of H2O. I'm going to try to find that first. You can use the conversion factor, which is what I'm doing here. Or you can just use a triangle to go from number of molecules to number of mole. But this conversion is going to be the same as 1 mole is 6.02 times 10 to the 23 molecules. So this is unknown of a given, and then from here you should be able to work out that the number of mole of H2O is 6.8 times 10 to the 15 over 6.02 times 10 to the 23. So I'm going to use a calculator here. So we have 6.8 times 10 to the 15 divided by 6.02 times 10 to the 23. So we have fairly small number, 1 point, hang on, let's go 1, 2, 3, 4, 5, 6. I lost count. 10 to the negative. Oh, I should have just done that. So 1.13 times 10 to the negative 8 mole. So this is the number of mole of H2O. And then from here, I should be able to work out the number of mole of water. Hydrogen. So number of mole of hydrogen for 1.13 times 10 to the negative 8 mole of water. It's going to follow a 2-to-1 ratio. So the number of mole of hydrogen is just 1.13 times 10 to the negative 8 times 2, which is, so I'm using exact values here, 2.26, actually it does round up to be the same, times 10 to the negative 8 mole. So this is going to be the final answer. Moving on to example 11, again I'm going to change this to 15 just so it's not as ridiculous. Now you can use the answer from the previous question here. So you need to find the number of mole of oxygen atom, but the number of molecules of water stays the same. So the number of molecules of water is still 6.8 times 10 to the 15 molecules. So I'm gonna use the answer here. So from example 10, I already know the number of mole of water. So this is from example 10. I know that the number of mole of water is 1.13 times 10 to the negative 8 mole. So this is the number of mole of water. So you need to go from the number of mole of water to the number of mole of oxygen. So we go number of mole of oxygen over number of mole of H2O. If you look at the subscript, you basically, for every water molecule, I only need one oxygen atom, which means that the number of mole of these two actually equal to each other. So I can just write the number of mole of oxygen to equal to the 1.13 times 10 to the negative 8 mole. So it will equal the number of mole, will equal the number equals to, I can't talk and draw a box at the same time apparently. The number of mole of oxygen would equal to the number of mole of water in this case. Okay, example 12, still using the same number of molecules, but the question here is how many moles of atoms? How many moles of, I don't even know why. Let's just not. How many atoms? How many atoms? Let's do how many atoms are in 6.8 times 10 to the 15 molecules. So how do you summarize the this how many atoms? So the number of atom is the unknown here. Now there are 3 atoms per molecule of water. So you're given the number of molecules, which is 6.8 times 10 to the 15 molecules. But there is one more piece of information that is not explicitly stated, but you should be able to deduce yourself, is that one molecule of H2O has 3 atoms, 2 hydrogen atoms and 1 oxygen atoms. So if you have this many molecules, if you just multiply this by 3, you should get the number of atoms. I can also create a ratio. The number of atoms over the number of H2O molecules is going to be a 3-to-1 ratio. For one molecule, you need 3 atoms. So from here, I can work out the number of atoms, which is going to be 3 times 6.8 times 10 to the 15. Whatever that is. 3 times 6.8. So I have 2.04 times 10 to the 16. And that is going to be the number of atoms. So I think the moral of this question is you really need to read the question carefully, or change the question in my case, to know exactly what it is that the question is asking you to find. All right, moving on to example 13. How many chloride ions are in 222 grams of aluminium chloride? So let's start by summarizing the question. It is asking for how many chloride ions. Now, if it doesn't say how many moles of chloride ions or how many chloride ions in mole, then you can assume that it is asking for the actual number of chloride ions, or capital N here. So I need to find the number of chloride ions. This is my unknown. And you are given the mass of aluminium chloride. So the only piece of information given is mass of aluminium chloride, which is 222 grams. So where do we go from here to there? Let's think about some of the other pieces of information that is not given to us, but we probably can use. Because I need to find the number of chloride ions, there is a high chance that I'm going to need to use Avogadro's constant, which is 6.02 times 10 to the 23. Also, in order to go from mass to number of particles, I probably need to find the molar mass. So I'm going to need the molar mass of aluminium chloride, which I'm going to calculate here. So it's basically the mass of aluminium, which is 27, and 35.5 times 3. So the molar mass of aluminium chloride, which you have to calculate using the periodic table, is going to be 133.5 grams per mole. So that's the second piece of information that I have to calculate. The third piece of information is going to be the relationship between the number of chloride ions and the number of aluminium chloride, mainly because the question starts with aluminium chloride and ends with chloride. So I'm just going to write a mole ratio here between the two. In order to make one aluminium chloride, you need 3 chloride ions if you look at the formula of aluminium chloride. So these are the 3 extra pieces of information that you need to work out yourself, and you should be able to do it. Without them, you can't really do the question. All right. So we're going to start by converting. This is our starting point. This is the only piece of information you actually have. So I'm going to start by converting the mass to the number of mole. So step 1 is I'm going to try to find the number of mole aluminium chloride. Because once I have that, I should be able to go to number of mole chloride ions and then the number of chloride ions. Okay, so the number of mole aluminium chloride, which is the unknown here, over 222 grams, which is the mass of aluminium chloride, is going to be equivalent to 1 mole over 133.5 grams. So this is the molar mass of aluminium chloride. This is the conversion factor. So the number of mole of aluminium chloride is going to be 222 over 133.5. So that is equal to 1.66. Once again, don't round, use the exact answer. Even though I just wrote 3 significant figures here, I'm not going to use 1.66. I'm going to use the number in my calculator, which is 1.66292, so on. So from here, we're going to go to the number of mole of chloride. So the second step is to find the number of mole of chloride ion, which is going to be, so number of mole of chloride ion over 1.66 mole, which is the number of mole of aluminium chloride, follows a 3-to-1 mole ratio. So the number of mole of Cl minus chloride ion is just going to be 3 times 1.66. So times this by 3, you should get 4.99 mole. Okay, well, yeah, I did create some room. So step 3 is to actually find the number of chloride ions. Now that I already have the number of mole chloride ions, you should be able to do this fairly easily using Avogadro's constant. So number of chloride ions over 4.99 mole, which is the number of mole of chloride ion, is going to equal to 6.02 times 10 to the 23 ions per 1 mole. So that's the conversion here, which means that the number of chloride ion, it's going to be 4.99 times 6.02 times 10 to the 23, which is that's wrong. Can't actually type things in the calculator. So I got 3.00 times 10 to the 24 ions. That's it. So that's 13. Let's look at 14. So a sample of calcium carbonate contains 0.25 mole oxygen atoms. So let's summarize the question again. So the question tells you the number of mole of oxygen, which is 0.25 mole, and you need to calculate the mass of calcium carbonate. So this oxygen is in calcium carbonate. So you're given the number of mole of one of the elements in the substance, and you need to work out the mass of the substance. So the unknown is the mass of calcium carbonate. Okay. Now, again, there are a few pieces of information that you're going to need to deduce before you can even do the question. First of all, there isn't any mention of the number of particles, like capital N, so I'm going to assume that I don't need to use Avogadro's constant here. However, there is a conversion, I think, that you need to make between number of mole and mass. So I think at one point, I'm going to need to find the molar mass of calcium carbonate. So I'm just going to do it here. So you need 40.1, which is the molar mass of calcium. Or maybe it is 40.1. We'll go with 40.1. So 40.1 plus 12 plus something 48 is going to be 101. So you work out, and you have to work out the molar mass of calcium carbonate. The other piece of information that I need is going to be the ratio between the number of mole of calcium carbonate and the number of mole of oxygen. And I need this because I start with the number of mole oxygen. So I need to be able to go from there to the number of mole calcium carbonate. So if you look at the subscript, for 1 calcium carbonate, I need 3 oxygen atoms. So that's the ratio between the two. So this is my starting point, and this is where I need to finish. So I'm going to start with the number of mole oxygen, and I'm going to convert from the number of mole of oxygen to the number of mole of calcium carbonate using the ratio that I just found. So this is going to be the first thing that I'm going to find. So number of mole of calcium carbonate over 0.25, which is the actual number of mole oxygen in this question, follows a 1:3 ratio. So the number of mole calcium carbonate is just going to be a third of that. So 0.25 divided by 3 is 0.0. You can just go with 1 over 12. 0.0833 mole, so something like this. And then from here, we're going to find the mass of calcium carbonate, which is the actual unknown in the question. So the mass of calcium carbonate, using the number of mole of calcium carbonate, which is 0.0833, this is going to follow a ratio of 101.1 grams over 1 mole. So this is the molar mass of calcium carbonate. So from here, I can just work out mass of calcium carbonate, which is 0.0833 times 101. And let's try to squeeze in the answer. 8.34 grams. Box final answer, correct to 3 significant figures. I don't actually need the extra space. Okay, final question. A sample of ammonium dichromate, this is ammonium dichromate, contains 1.26 times 10 to the 15 ammonium ions. Calculate the mass in grams of this sample. Well, this is actually not that exciting, but okay. So we start with the number of ammonium ions. I think the only exciting thing about this question is that it has a polyatomic ion in it. So the number of ion is capital N of NH4 plus, this is the information given, which is 1.26 times 10 to the 15 ions. And the unknown here is the mass of the sample. So the mass of ammonium dichromate, Cr2O7. So this is the unknown. Now, once again, there are a few things that you're going to need to find before you can start doing the question. First of all, because the unknown is in mass and the given is number of particles, I think that I'm going to need to use Avogadro's constant at one point, because I'm probably going to have to convert from the number of particles to the number of mole. The second thing that I'm probably going to need to do is to create a relationship between the number of mole of NH4 Cr2O7, so ammonium dichromate, and ammonium ion itself. So ammonium ion. So if you look at this, for one ammonium dichromate, I need 2 ammonium ions. So the mole ratio between them is going to be a 1:2 ratio. And the last thing that I think I'm going to need is the actual molar mass of ammonium dichromate, because you have to find the mass. So you're probably going to need the molar mass. You're going to have to do this yourself, so use the calculator. So 14 times 2 plus 8. I'm just calculating it here. 52. Okay. So 252 is the molar mass. This is not a number that I pull out of thin air. Like, I actually just did the calculation, so you have to do that as well using the molar mass of the element. Molar masses of all the elements from the periodic table. Okay, so this is all the information you're going to need to use in order to do this question. So because this is our starting point, I'm going to, I think, start by converting the number of particles, or the number of ions in this case, to number of moles. So my step 1, it's going to be finding the number of mole of NH4 plus. So the number of mole of NH4 plus over the number of particles, which was 1.26 times 10 to the 15. This is going to be the same as 1 mole over 6.02 times 10 to the 23. So this is how you can use Avogadro's constant into a conversion factor. And then from here, you know that the number of mole of NH4 plus ion is going to be 1.26 times 10 to the 15 over 6.02 times 10 to the 23. Okay, so we have 1.26 times 10 to the 15 divided by 6.02 times 10 to the 23. So you should get, it's a fairly small number. Hang on. Let's see. So 2.09 times 10 to the negative 9. Well, let me double check. Yep. Anyway, so that's step 1. And then from here, I'm going to find the number of mole of the ionic compound. So I'm going to find the number of mole of ammonium dichromate using the mole ratio that I just created earlier between ammonium dichromate and ammonium ion. So this over 2.09 times 10 to the negative 9, the mole ratio that I created earlier was a 1:2 ratio. So this is a 1:2 ratio, which means that the number of mole of NH4 Cr2O7 is going to be half the number of mole of ammonium ions. Okay. So I'm just going to have it 1.05 times 10 to the negative 9. I'm using the exact values though, so not the routed value. Final answer, or the final thing I need to calculate, is the actual mass of ammonium dichromate. Ammonium dichromate. Ammonium dichromate. That is correct. This thing is called dichromate. So this is, in order to find this, I'm going to have to use the relationship between mass and molar mass. So the mass of this over 1.05 times 10 to the negative 9, which is the number of mole, it's going to equal to 252 grams per 1 mole. So from here, I can find the mass of ammonium dichromate, which is 1.05 times 10 to the negative 9, which is the number of mole, multiplied with molar mass. So I think we have 2.64 times 10 to the negative 7 grams. Very small. That looks like a 9 grams. This is the final answer. Let me just double check. Yep, that's it.